Hello friends, now we find the formula for transverse velocity. What is the formula for transverse velocity? So we know that the transverse velocity is the velocity component which is perpendicular to the radius vector. So first we draw here, suppose that this is a curve at which the particle is moving and O is the pole, OX is the initial line. Let us suppose that at time t the moving particle is at point P. After del t time the particle is at Q point. Suppose that. So let at time t the particle is at point P and after del t time this is at the point Q. Here we suppose that there is a particle which moves on this plane curve. At time t the particle is at point P and after del t time it is at the point Q. Now we suppose that the polar coordinate of PB are theta. So an OP radius vector is small r, angle XOP is equal to theta. Here we suppose that the polar coordinate of PB are theta. So the radius vector OP is equal to small r and angle XOP this is equal to theta. Now we suppose that after del t time when this particle is at the point Q, so the polar coordinate of Q point is r plus del r and theta plus del theta. So the radius vector OQ is equal to r plus del r and angle XOQ this is equal to theta plus del theta. So this angle is theta plus del theta. Now we find the angle. This angle POQ. So angle POQ this is equal to angle XOQ minus angle XOP. So this is equal to theta plus del theta minus del theta. So this is cancelled out. So this becomes theta plus del theta minus theta. This angle is here theta and this is theta plus del theta. So this becomes del theta. We know that this is del theta. Now we draw perpendicular QL from Q on the radius vector OP. Draw a perpendicular from Q on. Draw a perpendicular QL from Q on OP. So here we find the transverse velocity and we know that the transverse velocity is the component of velocity perpendicular to the radius vector. So first we can see here in triangle QOL we find here sine del theta. Sine del theta is the perpendicularity upon hypotenuse. So this is QL upon OQ. And and we find here QL is equal to OQ sine del theta. Now we know that transverse velocity, this is equal to limit del t tends to 0 and displacement perpendicular to the radius vector in time del t divided by del t. We know that the transverse velocity is that velocity which is perpendicular to the radius vector. So we find here displacement perpendicular to the radius vector in time del t divided by del t. Here the displacement perpendicular to the radius vector is QL. So here is QL divided by del t. And QL, we know that QL is OQ sine del theta. So this is OQ sine del theta divided by del t. And we know that OQ is here R plus del R. So this is limit del t tends to 0 R plus del R sine del theta divided by del t. Now we put here expansion of del theta, we get R plus del R, and del theta is expansion of sine del theta is del theta minus del theta whole cube upon factorial 3 plus del theta whole power 5 upon factorial 5 and so on, divided by del t. Now we neglecting here powers of del theta. Neglecting powers of del theta, so we get limit del t tends to 0 R plus del R del theta divided by del t. Now this can be also written as limit del t tends to 0 R del theta plus del R del theta divided by del t. Now also we neglect del R multiplied by del theta, so we get neglecting del R multiplied by del theta, we get this is equal to limit del t tends to 0 R del theta divided by del t. When we take limit, we get here R d theta divided by dt. So we get here velocity, transverse velocity, this is equal to R d theta upon dt, or this can be written as R theta dot. So this is the transverse velocity. Thank you.